I'll present to you today a bit more of a specific couple of use cases to give you an idea from the industry perspective. I'm CEO and co-founder of Skyborne Technologies, and I'm also a director of another company called Athena Artificial Intelligence. So today I've been asked to present on the industry outlook, so I'll be representing these 4 companies today just to give you a broader perspective. So Skyborne Technologies itself does air robotics. You can see a few examples on the table here. Cyborg Dynamics, CEO Stephen Bornstein's an Army reservist who was asked to present here in my place, but he's on leave. Him and BI5, they do ground robotics, and the common software that kind of links everything together is the Athena Artificial Intelligence. So Stephen Bornstein, being a reservist, knows how to talk the right language to defence. I don't, so please forgive me as I'm going through that section of the slide. So a little bit of background. Hypersonics was mentioned as an intense strategic interest for Army and other aspects of the ADF. That was where I actually came from. So I did a PhD in missile guidance in the hypersonics department at UQ, and then ended up doing a postdoctoral research position on this project here. So this project is called the Scram Space 1 Hypersonic Flight Experiment. It went from 2009 to 2013. Our experiment was the little blue thing on the end. The other stages there are just rocket stages, one from Brazil, one from the US. I'll just give you a bit of an overview of what this experiment was meant to do. So this is a simulation run by DST. That's the first stage separating, and soon you'll see the second stage separating. The reason it's spinning is to take out any thrust misalignment from the rockets, so it's essentially spin stabilised. It's a little nose cone popping off. So this thing's got a scramjet on board. The whole idea of this is to test air-breathing engines at Mach 8 on re-entry. My job in this project was this period here where you're outside the atmosphere. So you basically skim low Earth orbit level at 330 kilometres. I had 4 cold gas thrusters which would fire in pairs to deliver roll, pitch and yaw moments to realign the thing so it's pointing the right friggin' way when it comes back in the atmosphere. If you're off by a little bit, the scramjet doesn't work. Around 27 kilometres altitude, the whole thing just melts due to air friction. So this is a little bit of a video of the campaign we did in Norway. So this is my reaction control system doing the reorientation. That's the scramjet hydrogen firing into the chamber. So that's called hardware in the loop, where you trick the flight computers into thinking that it's doing what it's doing. If you can pause the video here. So this is a big collaborative effort getting this thing up and running. So the UQ component was only a small part of it. We made the payload. The Germans bolted the rocket stack together for this Norway launch. So this is the second stage. It's a improved Orion. It's part of a surface-to-air missile system. All right, and this is the actual launch, taken from a couple of perspectives. So this was 2013. Here's everyone running for cover. So this is a slow motion of the launch itself. What you'll see is a little explosion at the base of the rocket and a little piece falling off. You'll see it very soon. That bit there. So that's part of the rocket nozzle falling away. This is the whole rocket stack spinning around laterally, which flicked the scram space and the second stage rocket off. Second stage rocket avionics detected a separation. And you'll see the second stage rocket about to ignite. That's the first stage. So there's the second stage, flying horizontally straight towards the town of Anderness. The rocket, the second stage in our payload ended up at the entrance to the harbour of this town, missing a boat by about 50 metres. It was the second worst rocket disaster at this Andoya test range in history, the worst one being the Black Brant launch by the US in the early 90s, which was a weather experiment. It veered off course and started heading towards Russia. There was a comms breakdown between the rocket base and the Russians, and Yeltsin apparently had the nuclear suitcase open, ready to hit the retaliate button. You look it up on Wikipedia. Anyway, that was a 4-year program, 4 years of my life for this one failure. And what it really showed me is I really wanted to get into something where you can fail faster and iterate and get some technology up. So I founded Skyborne Technologies with a couple of guys. So what do? We make smart aerial robotics for defence and security customers, mission critical technology solutions, all of that marketing hype. Our flagship product is what you see in front of you here. So this is the Cerberus tri-tilt rotor. We were founded in 2014. We've got 17 staff, soon to go on 20 as a result of an Innovation Hub grant coming through. Most of our company is R&D engineers. So a lot of companies in Australia who try to sell to the defence market are simple resellers of overseas equipment. We do most stuff here ourselves. So we've got a small facility in Murarrie. We've got a weapons armoury, so we're licensed to carry Category R systems like you see in front of you. We've got a milling machine, a mechanical workshop, electronics lab, essentially enough to do rapid prototyping in small quantities. And if we go to any production scale thing, we outsource that. So I'll briefly run through the products that we've got, and then I'll look at some of the other companies' products and that collaborative effort that we're going through. So this video introduces the Cerberus GL. So this is the 5-shot grenade launcher we developed as a result of a SICP grant here in Australia. Once we found out that no one really makes grenade launchers in Australia. So as you can see, the principal mechanism of aiming this weapon system is to tilt the whole airframe up and down, which has lots of advantages over a gimbal. This is about the 4th generation of Cerberus. That we've had quite a history with this thing since the company founding. This latest one allows you to pack it up and put it in a backpack. So we're still in the dismounted combat soldier territory. You can see the ground control station there with what we call open sights targeting. I'll cover that in a little bit. So right now we're around TRL 6. It's not waterproof yet, doesn't have hardened comms. We'll be developing a lot over time. So this was the last time we fired in the US. So that was as part of the AWE Army experiments for the US Army. It was really fantastic over there. We rocked up at the test range and they said, here's the keys to the test range, here's a bucket of ammunition, go nuts. And we haven't fired since because of the regulatory environment in Australia, which is a bit of a shame, but we're working on it. You've seen the main features in the video. It's all about precision strike at the dismounted combat level. I've seen plenty of videos on YouTube of US soldiers under fire in Afghanistan. I know Afghanistan's wrapping up and we're moving on from that. A few years ago, and they're just sitting around waiting for the gun line or waiting for fast jet support. If they had a system like this, they could go and retaliate or at least get out of danger. So it's really about protecting the soldiers, letting robots do the heavy lifting rather than having to aim a gun. You're aiming through a screen, and it's still at that tactical level. What's great about the Havoc launcher that we like is that it's a chamber select in flight, so you can load up different round types and choose the most appropriate one for the mission. So non-lethal rounds, flashbangs, that sort of thing, smoke for target designation, or high explosive. So just a few specs on it. It's about 10 kilograms unarmed with a 20 or 30 minute endurance depending on how many rounds you put in. It's not very competitive on the endurance side of things compared to some ISR assets who might be useful. But those ISR assets don't have to carry a 3 kilogram weapon system. So this is, the futurist presentation earlier, is Anders still here? I'm not sure. But what he showed, that Slaughterbot video, is quite unrealistic right now with current technology due to these considerations of endurance, energy density in batteries, etc., which Michael Milford touched on earlier. So it's got a laser rangefinder for the targeting fire control system, as well as your standard EOIR. So why this platform? So there's a few advantages with this style of thing. The first you've seen is the tilt mode, the ability to aim the weapon system up and down, as opposed to using a gimbal. Who's familiar with the EOS remote weapon station? Yeah, a few people have seen it or used it. The size of the gimbal mechanism for the size of the weapon is probably 3 or 4 times bigger. If you apply the same principles to something like this 40mm launcher, your drone ends up around 40 to 80 kilograms or so. What's great about this is that we line up the firing axis with the vehicle. It means recoil doesn't have big attitude disturbances to it. It just pushes the vehicle back, and it makes the whole thing a hell of a lot lighter. Tricopters are more efficient than quad hex octocopters in hover by about 5 or 6%, not much. A helicopter with a single large rotor is the best system for hover, which is why the Black Hornet Nano UAS is such an amazing platform. You won't be able to get a quadcopter with the same endurance for the same size and weight. And finally, we have our own proprietary flight computer and controller. So most companies and teams grab an ArduPilot or a Pixhawk or something off the shelf. We've actually written the whole operating system and everything from scratch. And when you talk about sovereign capability, that becomes quite important. So you would have seen the AeroVironment Switchblade. This is where we kind of fit in the market against those sort of systems. There's a number of advantages this kind of multi-shot reusable drone has, and I'll go through 5 of them. The first is cost. We're orders of magnitude lower cost per shot. So an HE grenade round might be $100. An AeroVironment Switchblade's between 100 and 150 grand per shot. So we're orders of magnitude cheaper. Since we're multi-shot, you can engage the target, do ISR, battle damage assessment, with the same asset that delivered the effect, and then have another go straight away. With these loitering munitions, you can't do that. You've got to have another asset in the sky. Speed of effector, that's kind of obvious. You shoot something fast, you might be able to hit a moving target compared to a loitering munition. I've mentioned the operational flexibility. I'll touch on the modular variant of this later, but even with the 5-shot grenade launch, you can load up those different round types and do different missions. We've got a couple of FNP90s on order, see how they work out. We've got some smart munitions, I'll cover that later. And we've also done a 12-gauge variant for the UK MOD for urban operations. So with the same platform, you can load up lots of different things, and it's very versatile. And finally, the US Army had a lot of complaints about the Switchblade, in that when you're operating in urban environments, it just doesn't have the turn radius, the ability to keep track of targets. So very often they'd lose their target through an alleyway or something and just veer the thing off and crash it in the desert. What we tried to do with this system is combine the things that soldiers are familiar with. Some of you might have done DJI Phantom training, just standard drone training. We've replicated the controls of that. Instead of being able to take a picture at any grid reference within, say, a 3-kilometre radius, our objective is to enable you to deliver an effect within that same radius. And we also combine something you're also familiar with, so that's your standard point-and-click interface with the rifle. So what we've done is put our aiming on the right-hand side. So you aim with the right hand and arm and fire with the left hand. So we get some criticism about the size of this controller, but I want to tell you a story. You know, this integrated S9 device that flips down from your webbing has its advantages. But we took this thing out in the field in the US. We didn't have this controller. A speck of rain landed on the arm button, and had another speck of rain landed on the fire button, that thing would have just discharged because of the touch-sensitive nature of the touchpad. So we've made those buttons physical buttons. So we don't mind what ground control station we end up using, as long as you've got a physical arm and fire button to avoid those kind of mistakes. So this is the Cerberus MI concept. So in addition to the grenade launcher style of thing, you've got all these other options. So you probably can't see the writing too well. At the top left, there's the signals dispatch carrier. So going back to the old carrier pigeon days, putting an encrypted hard drive on board and sending sensitive information around the battlefield autonomously. It's a little bit more expensive than a pigeon, probably less reliable too. CBRN sensors, electronic warfare sensors. You know how contested this space is going to be. The guys up in Townsville wanted the M72 law on board, so we'll see if that stays around. During our contract negotiations, we're not sure. The US Marine Corps wanted a laser designator on this so that they didn't have to put their Apaches in the way of harm. They could just send up an autonomous vehicle. And finally, I'll round off the Cerberus aspect of this presentation with the latest test firings. This was actually this week for the UK MOD. So this is a 10-shot 12-gauge undergoing weapon system integration qualification. All right, the other main system we're developing at Skyborne is the Gannet glide drone. So this one here. This was sponsored by the Dismounted Combat Program. Essentially, two of these store underneath the Cerberus, and when it gets deployed, it flicks the wings out and the elevators and basically cruises into target. So that's essentially a miniature cruise missile, again at the dismounted combat level, really allowing you to assemble that combat mass together. And this system came about due to feedback about the grenade launcher's range. To be effective with the grenade launcher, you've got to be within, say, 50 to 150 metres of the target. And if you're that close, you can be seen or detected acoustically, by radar, by electronic detections. You really want that extra standoff distance in certain circumstances. So the idea is that you can drop this from, say, a few kilometres away and still hit the target. It's designed to operate in two different mechanisms. One is a very RF active system, so the thing's spamming out RF information and communicating with other members of its swarm. and so you can have your simultaneous strike. The other mechanism of employment is a very RF silent mode. So this is, you may not have GPS, you may not have good comms. So we'd have a very high-grade IMU on board so that it can hold itself together over that couple of minutes of flight. It's also designed to do a terminal effect dive, so it'll fold the wings back and fire straight down on top of a target. The warhead itself, this is a replica, obviously. This is made by DST down in Adelaide, 600 gram with a shaped charge in the end, or explosively formed projectile. So that can get through about 60 mils of steel. So it's not a tank killer, but you should be able to do some damage. This gives you some idea of the range of the strike. So if you're up 200 metres with a 10 to 1 glide ratio, you should be able to hit 1.5 k's down range or so. So the first flight test for this likely in September. So it's very low TRL compared to the Cerberus. And finally, I'll just finish up the Skyborne slides with a couple of future concepts. So this was done by our graphic artist. This is kind of a delivery mechanism for long range, multiple swarming strikes. This is the Cerberus Hunter Killer. So this is a smaller scale than this platform, but it's designed for a counter UAS. So none of these things we're working on. These are just concepts we're floating around to give you an idea of the kind of technology horizon. So the idea behind this is not to optimize for endurance, it's to optimize for speed and agility. So you've got completely different designer propellers, and you probably have a single shot 12 gauge to take out the other drone. And then of course, everyone wants more capability, more endurance. So this concept is simply around scaling things up. So you might have 4 M72s or 8 glide bombs or something like that. Effectively a gunship at the company or battalion level or something like that. So it's no longer man-packable. There's plenty of competition in this space, so we may not head down that path, but that's just throwing some concepts around. And then of course, so this was floated a few years ago as a Cerberus recon. So you replace the front landing gear with a set of robotic claws and some clever machine vision from folks like Michael down the front here, and be able to grip onto tree branches and fences. So you've effectively got a system that can sit there and perform ISR over a day instead of limited to 30 or 40 minutes endurance. If you put an effector on that, a sniper system or something like a P90, you've effectively got a rapidly deployable remote weapon station. So think about all the potential uses that might have in denying lines of retreat and that sort of thing. All right, is there any questions on the Skyborne side of things before I jump into the presentations on the other systems? Yes?
I'm just wondering, it looks like it's really operator really stabilised and it's not going to retire or really time.
Yeah, it's a good question. So right now you can kind of do your standard waypoint kind of autonomous. It's got auto landing. I think you've still got to take off yourself, but that's not a technical issue. In terms of automatically locking on, that's in our pipeline. So when I go to the AI presentation, so that we can do some detections on the edge, we can potentially slew the weapon system to target, but then the human will always have the final say in it. All right, so this isn't my product, so I'll be fairly brief. This is the Warfighter UGV. BI5 is founded from the technical guys at CERT, the Police Rapid Response. So they put together this UGV to kind of barge through doors in hostage situations and that sort of thing. And it's been in action. So, you've got the terrorist there with a hostage, he's armed, you barge one of these things through the door, they don't even know what to do. It's like, okay, I surrender. And that's happened a couple of times. So really amazing use of these robotic platforms. Cyborg Dynamics Engineering are essentially modifying that for ADF use. So here are some of the potential configurations. You've got the assault configuration with the EOS weapon gimbal. CASEVAC, logistics carry, and then this combined ISR concept. So just go and plant it there for days on end, gathering ISR, and you can also put a drone on it as well. So this system's been tested. I think it's fired 50 cal out in the desert. So it's around a 500 kilogram thing. I suppose the important parts for you are the transportation. So you can fit 2 in an MRH-90 or 12 in a Chinook. And there's a paper study being done on incorporating the Spike LR2 on this. So this is a really small platform. It's, you know, maybe just over a metre long and less than a metre wide. If you can take out 2 main battle tanks with one tiny little system that's a fraction of the cost, I think it was brought up earlier, will the main battle tank be a mainstay in the future of warfare? Perhaps not with systems like this. The great part about unmanned systems, if you think about the history of vehicles, aeroplanes and tanks, you've always got to fit a person inside it, and that dictates the minimum size. But you look at the size of what's needed for a lethal effect to counter such things, it's orders of magnitude smaller. So this is what we're kind of facing as we go into the future. Again, some more on the ISR asset. So this system here we're working on now, your standard EOIR, but also incorporating acoustic sensors. So you can do some shot detection algorithms and that sort of thing. And this is the Galaxy S9 concept that you might be familiar with. Everyone's kind of moving towards this common ground control architecture, that sort of thing. So again, this will work for the Cerberus. You just need a separate controller with the arm and fire button. So these are some of the features of this UGV. Some of them are in place now. This is an active Defence Innovation Hub grant. Some of those are in place now. You've got a driver camera. Then you've also got a number of autonomous modes. So drive it around on your own, have a bit of fun, or plot waypoints, follow me mode, or you can put it in a patrol pattern. And the topographical map allows you to do that planning. All right, so in the last 10 minutes or so, I'll discuss Athena Artificial Intelligence. What this system does is act as a software as a service type system to enable various robotic platforms and other elements of fires to intelligently talk to one another. And the main emphasis behind this system is to reduce sensor-to-shooter times in a legal and ethical manner. So any ISR feed, essentially, from a drone, either at the small, medium, or the strategic asset level, can be fed into the Athena AI system. And here's some example of compute hardware in the bottom left there. You've got little Jetson nano GPUs in the little one. So that's designed for soldier mount or vehicle mount. Then you've got the compute heavy unit, which is much more powerful GPUs. You can put in a server rack at the forward operating base. It's also designed to be integrated into the battle management system. So whatever that happens to be, we're not pretending to want to be a battle management system, but we're aiming to be a plug-in to whatever that turns out to be. So what the hell does it do? Well, it does those 5 things you can see underneath. So Michael Milford gave a great presentation on vision AI. So it does a fair bit of vision AI to recognise defence objects of interest. So that's object categorisation. It does this under a legal and ethical framework. So you load in your laws of armed conflict and your ethical considerations. And it does advanced blast modelling, allows tactical decision support. And then those top 4 are really the tactical in real time aspects of this system. Then the geospatial terrain analysis is really a pre-planning or pre-mission system. So this is what the Vision AI does. So in the top right there, you can see some object detections. So it's detecting soldiers. We'll use a 2-stage AI system. The first stage detects big objects from your large ISR feed. Is it a military vehicle? Is it a person, essentially? Once those are detected, the cropped images are sent to a second layer, which divulges more information about it. Is that person armed? What sort of vehicle is it? Then the decision support, you preload in your laws of armed conflict, drone maximum altitude, no fly areas, no go areas, and it can do some decision support around that. What you see there is the effective casualty radius in the green circle on the bottom right there. We've done some optimization of the user interface. So this might be a good time to talk about the fact that, okay, you're an operator, you're looking at a screen. If you get spammed with all these detections, oh, this is a soldier, this is whatever, you're just going to be operator overload. You're going to be like, I don't care about the system, I'm just going to turn it off. One of the critical aspects of this program is to determine whether this actually saves the operator time and provides better decision making, or better decisions are made after having used this. So that's the final kind of chapter of this development cycle, to go through those user trials and make sure the system actually works. One thing that Michael also mentioned was the data that feeds in. When we first started this program, we were labeling 2,000 images by hand in a week. Very tedious work, effectively hiring like grade 12 work experience students to do that. And we very quickly moved on to synthetic data generation. So the problem with using real data, and we collected that ourselves with phantom drones and that sort of thing, running around with gel blasters, getting the police called on you because you look like hooligans. We went from that to this system where we use synthetic AI. So we use the Unreal 4 gaming engine to generate images, different lighting conditions, different occlusions, to make sure that the AI resultant neural network is balanced. So now we label 10,000 per day, essentially overnight. And that's really important when you start to consider things like mission tactical networks. So let's say you're doing an operation, the enemy's now using a brand new vehicle type or a brand new weapon system you've never seen before. You need the ability to rapidly train the AI system and redeploy it. So that's where this synthetic data really comes in handy. So to date we've trained 50 classes or so. So it's a multi-layered neural network. We add some tracking algorithms so that, to give you an example, the GPU on board here can process the AI at about 5 frames per second. If there's too much stuff going on, it slows down even more. So what you need to do is be able to track those detections in between AI detections. So we add some tracking in. We've done some training in the electro-optical spectrum, low light and thermal. So you can see some thermal AI training. It's picking up the weapon as well as the person. And also pose detection. So where does pose detection come into this? So with the blast effects modeling, we can get accurate casualty estimations. So if someone's in prone position as opposed to standing, they're presenting less surface area to the potential frag blast, and the percentage of casualty will go down. So that really takes things to the next level. That's done in real time. You're not sitting there with like a protractor or a slide rule. I don't know how you do it. I didn't go through the... but that's happening in real time. Again, shortening that sensor to shooter time. One of the pre-planning mission tasks you'll do with this system is load up your attack guidance matrix and your high-value targets, so that when you go out on the mission, you've got this ISR feed, you should automatically be able to select the right fires system, whether it's a 40mm or a 155 from the gun line, to queue onto target. So you should be all automatically produce fire missions and contact reports and situation reports rather than filling them out manually. As you, say, zoom out on the topographical map, if you've detected a couple of, let's say 5, 6 individual soldiers, it will automatically relabel that as a squad rather than have all the detections pop up. So to try and give you the breadth of what this system is capable of doing, and it's not all there right now. This is under development, but this is where we're headed for. So it's quite a task. As I've mentioned, the high fidelity blast modeling. So we run the trajectories from your fire tables for 155, or if it's a guided weapon, we just take the CEP of the guided weapon and load that up. What we're aiming to do in the future is to be able to classify what a building is likely to be made of, so that we know with a bit more certainty what the blast effect is going to be. If it's concrete, it won't get through. If it's made of wood, it might get through. So this is the sort of thing you can kind of do in real time, theoretically. So this is quite powerful. What you see in the top right-hand corner there is also an idea of if you've got someone behind a ridge or something, can your trajectory-based weapon actually get there? This gives you an idea of the tactical kind of view and the sort of detections. Michael mentioned earlier about reporting 100% perfect AI. AI vision detections are a statistical thing. If anything ever says 100%, it's wrong. So this is the kind of confidence interval you can expect. And then finally, this is the geospatial AI. So what this does, you essentially load up a 3D point cloud. It might be an open source data set at 20 or 30 meters resolution to start with. You might need more fidelity. Grab whatever data set you can from an ISR asset with a laser scanner or wherever you get your data from. Grab the satellite vision of that and do a segmentation analysis. So what that looks like is this. So there's your satellite data in the top left of that figure. You do your AI detections on buildings, roads, water, etc., and you can do this segmentation analysis. That allows you to then do clever route planning for autonomous vehicles such as UGVs. So that's a very short version of Athena AI and the capabilities of this kind of consortium that all hangs out with us. So I hope you've enjoyed the presentation. Cheers.
Question.
Yes.
What sort of data link will Athena AI use to send and receive on your mobile drone platforms with your ISR assets?
Yeah, so it really depends on what you want. So right now we're just using 2.4 gig encrypted comms, and then the ground control station, in the example we gave to the Hum-T demo, just operated over Wi-Fi to a central server to do the processing. We're trying to be comms agnostic, so whatever comms are being used, we'll try and adapt into that as long as we've got the bandwidth to do it.